Previously, we practiced again with calculating constant of proportionality and unit rate. Now we're going to use that to write equations and solve problems. So Hosea skateboards from his house to his school, which is 4 miles away, in 20 minutes. If his speed is constant, what is the constant of proportionality in miles per minute? So this is going to be y divided by x. So if I set up my table, minutes, miles. So I've got 20 minutes, 4 miles, and I'm dividing miles by minutes. So 4 divided by 20, we can do this as a decimal or reduce it as a fraction. 4 divided by 20 is going to be 0.2 miles per minute. I could also have divided this by 4 and this by 4 to get 1/5 of a mile per minute. Either way is fine. So now what I'm going to do is I'm going to write my equation. D is the distance he traveled, so miles is D. We're going to do T, which is time, so minutes is T. Now I have to figure out how to write my equation. What we learned last time is that when we've set this up like this is our x, this is our y, so we're always going to multiply whatever our constant of proportionality is times x, and that's going to give us y. And this was something that was really confusing for people. So now that we're really being careful with our units, I want to show you another way to check this and make sure that it makes sense. This 0.2 is in miles per minute. This time is in minutes. And this distance is in miles. What should always happen is that whatever you're multiplying by, here I have minutes in the denominator, here I have minutes in the numerator. These minutes divided by minutes are going to divide out to be 1, and I'm going to be left with some number of miles equals some number of miles. This is right. You know it's right if the units divide each other. In contrast, let's say I had written it like this. So this is wrong. If I had written it as 0.2d, excuse me, d equals t, then I would have miles per minute times miles equals minutes. And that's not right. Here I would end up with miles times miles over minutes, and these miles wouldn't divide out. So this is wrong. And we can see that that works out when we try to solve problems. So here, how far could he go in 40 minutes? So 0.2 miles per minute times 40 minutes equals how far he could go, so some number of miles. So this makes sense. 0.2 miles per minute times 40 minutes, that is going to give me how many miles? So 0.2 times 40, 8 miles. Similarly, how long would it take him to travel 5 miles? So I've got 0.2 miles per minute times some number of minutes. I don't know how many it is, so let's say t. It's going to give me 5 miles. So this is right, those units are right, miles is going to equal miles. So 0.2t equals 5. Here, I'm trying to undo this multiplication. I'm not multiplying 0.2 by t. I'm trying to figure out 0.2 times what gives me 5. Times what is division. So I'm going to divide by 0.2. Five divided by 0.2 is going to be 25, and that is in minutes.